Hello guys, hope you're doing well. Today we will continue our lesson space geometry by talking about line in space. So, the first objective of this video is how to find the parametric equation of straight line. And the second objective of this video is to study the relative position between two straight lines. Now let's start by equation of straight line. A line is unique if it passes through a given point and has given direction, or passes through two given points. So, in this figure we have a line D, and V is a direction vector of the line D, and we know that the straight line has at least one director vector which is confounded or parallel. So, we have an infinite director vector of line D, which they are parallel or confounded to D. Let's talk about the first case. Its line passed through a given point and it's parallel to a given vector. For this, take a line D and M, X, Y, Z be a variable point on D, where this line D passed through a fixed point A and have a direction vector V. So, the two vectors AM and V are collinear, therefore exists a real number T where AM vector equal TV. Go now to the coordinates. We get XM minus XA equal TXV, YM minus YA equal TYV, and ZM minus ZA equal TZV. Replace XV, YV, ZV by A, B, C. Therefore, the parametric equation of line D in the form of X equal AT plus XA, Y equal BT plus YA, and Z equal CT plus ZA, where ABC is the director vector of the line D. One of the director vectors. Second case, line pass through two given points. Let D be a straight line pass through two fixed points A and B. So we need to find the parametric equation of the line AB. For this, take a variable point mx, y, z on D. Then the two vectors AM and AB are collinear. Therefore, exists a real number T belong to R, where AM vector equal TAB. Go to the coordinates of AM and AB. We get XM minus XA equal TXAB, YM minus YA equal TYAB, ZM minus ZA equal TZAB. Therefore, the parametric equation of AB in the form of X equal TXAB plus XA, Y equal TYAB plus YA, Z equal TZAB plus ZA. The conclusion is, to find the parametric equation of a line AB, we need to find one director vector of this line AB. It's the vector AB. Then this line D pass through two fixed points. Take a variable point M. AM and AB are collinear, so exists T belong to R, such that AM equal TAB. By replacing the coordinates of AM and AB, we get the parametric form of the line AB. Now let's go to an application. Find the parametric equation of straight line AB where A 2, 4, Z and B minus 1, 2, 3. We see in this figure the point A and the point B, and this is the line D. We need to find the equation of this line D. First step is to find a director vector of the line AB. It's the vector AB. Now let's find the coordinates of the vector AB. We get AB vector minus 3, minus 2, minus 4. Second step, put the parametric form of any equation. So AB is equal to X equal minus 3t plus 2, Y equal minus 2t plus 4, and Z equal minus 4t plus 7, where T belongs to R. Minus 3, minus 2, minus 4 is the coordinates of the director vector of the line AB. And 2, 4, 7 is a fixed point on AB. It's a point A. We can put here the point B. Same result. Now the second objective of this video is talking about the relative position of two straight lines. We have different position between two straight lines. Let's start by the first position, is parallel or confounded. So consider the two straight lines D and D prime, where U and V their director vector respectively. First step, we need to check up if the two director vector of these two straight lines have the same direction. It means that parallel or confounded. For this, we need to find the cross vector of these two vectors U and V. And if the cross vector of these two vectors equal to 0, then the two vectors U and V are collinear, so the two lines D and D prime are parallel or confounded. Second step, to check up if D and D prime are parallel or confounded, we need to take a fixed point on the line D, by example A, and if this point A on D prime, then D and D prime are confounded. But if this point are not belong to D prime, then D and D prime are just parallel. In this figure, we have two lines D and D prime, where U is the director vector of D and V is the director vector of D prime. We see that these two vectors U and V are collinear. Then the two lines D are parallel. They are not confounded here, since if we take a point A on D, we see that this point does not belong to D prime. Then they are just parallel. But in this figure, we see two lines D and D prime having same direction, yes. And if we take a point A on D, we see that this point also on D prime, so D and D prime are confounded. Now let's go to an application about this. So consider the two straight lines D of parametric equation x equal m minus 1, y equal 2m plus 3, and z equal minus m, and D prime, another line of parametric equation x equal 2t plus 3, y equal 4t minus 2, and z equal minus 2t plus 5, where m and t are two real numbers. The question is to study the position of D and D prime. First step, we're gonna find a director vector of D and a director vector of D prime. For D, it's 1, 2, minus 1. For D prime, it's 2, 4, minus 2. Let's study the position of these two vectors. We see that V of D prime is equal to the double of V of D. Then VD and VD prime are collinear. We can prove this by use cross vector of V of D and V of D prime. So if the cross vector of these two vectors equal to 0, then these two vectors are collinear. Now, since the two vectors are collinear, then the two straight lines D and D prime are parallel or confounded. Let's check the final result. Now, for this, take a point on D. For m equals 0, we can take a point on D. So for m equals 0, we get x equal minus 1, y equals 3, and z equals 0, named A. So A minus 1, 3, 0, it's a point on D. Let's check up if this point belongs to D prime or not belong. So by replace x by minus 1, we get t equal minus 2 from the first equation, and by replace y by 3, we get t equal 5 over 4. Then there exist two different values of t, which is impossible. Then A does not belong to D prime, so the two straight lines are parallel, not confounded. Now let's talk about the second position, intersecting lines. Consider the two straight lines D and D prime, where U and V their director vector respectively, If the cross vector of these two vectors are not equal to 0, it means there are no real number k such that u equal k times v, then the two vectors are collinear. Therefore, the two straight lines d and d prime are intersecting or skew. What I mean by skew, it means that these two straight lines are not belong to the same plane. How to check up if these two straight lines are intersecting or skew? Now, second step, we need to solve a system by put x of d equal to x of d prime and y of d equal y of d prime. By solving this system, we can find the variable parameters, and we need now to substitute these parameters, the result of these parameters, in z of each line. If they satisfy left side equal right side, it means that same z, then the two straight lines are intersecting. But if no, otherwise they are skew. An example about this. Consider the two straight lines d of parametric equation x equal m, y equal m minus 2, z equal to m plus 1, and d prime x equal t plus 1, y equal to t, z equal t plus 2, where m and t belong to R. The question is to study the position of d and d prime. First step, we need to find a director vector of d and also a director vector of d prime. 1, 1, 2 for d and 1, 2, 1 for d prime. Let's check up if these two vectors are collinear or not by finding the cross vector of these two vectors. We get in the form of a matrix by put I, j, k in the first row, in the middle the first vector vd, in the last row the second vector vd prime. By calculation we get the cross vector equal minus 3i plus j plus k does not equal to 0, then v and d, v of d and v of d prime are non-collinear, then the two straight lines are intersecting or skew. Second step, it's check up if these two lines are intersecting or skew. We need to form a system of equation by put x of d equal x of d prime, y of d equal y of d prime. Then we get m equal to t plus 1, m minus 2 equal to t. By solving this system, we get m equals 0 and t equal minus 1. Now, replace this m by its values in z of d. Then we get 2 times 0 plus 1 is equal to 1. And replace this t by its values on z in z. We get minus 1 plus t equal 1. Then the same result, same z. Then the two straight lines are intersecting at point. We need to find the coordinates of this point. By replacing m by 0 or 2 by minus 1, we get the same result. Then if we replace m by 0, we get x equals 0, y equal minus 2, and z equal 1. Then the two straight lines are intersecting at point A, 0, minus 2, 1. Now another application about this. So, consider the two straight line d of parametric equation x equal t plus 1, y equal 2t minus 1, and z equal t minus 1. And d prime x equal 2m, y equal minus m plus 1, and z equal m plus 1, where m and t are real numbers. The question is also to study the position of d and d prime. First step, we need to check up if these two straight lines are parallel or not by finding one director vector of d and one director vector of d prime. So 1, 2, 1 for d, 2 minus 1, 1 for d prime. Find the cross vector of vd and vd prime. Put them in the form of a matrix. In the first row I, j, k, in the middle v of d, in the third row v of d prime. By calculation we get the cross vector vd cross vd prime equals 3i vector plus g vector minus 5k vector does not equal to 0. Then v of d and v of d prime are non-collinear, so D and D prime are not parallel. It means that D and D prime are intersecting or skew. Let's check up if they are intersecting or skew by form a system of two equations by put x of D equal x of D prime, y of D equal y of D prime. Then we get this system. By solving this system, m equals 3 over 5 and t equals 1 over 5. Replace m by its values in z of D prime and t by its values on z of D. We get z of D prime equal to 8 over 5, z of D equal to minus 4 over 5. Different values, then D and D prime are skew. They are not belong to the same plane. Another position of two straight lines is orthogonal lines. Consider the two straight lines D and D prime, where U and V their director vectors respectively. If U dot V now equals 0, then U and V are orthogonal. Therefore, D and D prime are orthogonal. An application about this, consider the two straight line D of parametric equation x equal t plus 1, y equal 2t minus 1, z equal t minus 1, and d prime x equal to m, y equal minus m plus 1, z equal m, where m and t belong to R. Let's check up the position of these two straight lines, or the question is to show that d and d prime orthogonal. So let's find the director vector of d 1, 2, 1, and director vector of d prime 2, minus 1, 0. Dot product of these two vectors equal to 0, then V and VD prime are orthogonal, therefore D and D prime are orthogonal.